We now want to look at some variants of the goods market model. So far, we looked at a simple case in which only consumption depends upon income, right? So we looked at our standard or basic goods market model, which is given to us over here as where consumption was a linear function of disposable income, investment, government spending, and taxes are exogenously given, and we have a closed economy, right? So far, we've only looked at the case in which only C is a function of Y. Now we want to look at a variant of our goods market model in which not just C, but taxes also depend upon income. So far, we had T is equal to T bar, but now we want to allow taxes to depend upon Y. Now, taxes typically tend to be higher when income is higher. So it's more accurate to allow T to be an increasing function of Y. So if we go back, initially in our model, the assumption was, that T is equal to T bar over here. But now here we also mentioned that we'll study an extension of our model in which we'll relax the assumption that taxes are fixed. So now what we're going to do is we're going to consider the case where taxes, they're an increasing function of Y. So instead of T is equal to T bar, we'll add this equation where taxes have an autonomous component T naught and an induced or income related component T1 Y. So now our model is otherwise the same as before. C is still a linear function of disposable income. I, G are still exogenously given, and we're still looking at a closed economy. But now instead of T is equal to T bar, we have T is equal to T naught plus T1 Y. Now we can solve for equilibrium income exactly as before by setting Z is equal to Y. So the way we solve for equilibrium income will be exactly the same. You find your demand schedule Z, set it equal to Y. The only difference being that now instead of using T is equal to T bar, you will use T is equal to T naught plus T1 Y. Right? So if we go back when we originally, like over here, yeah, so we said equilibrium output is where Y is equal to Z, right? Where Z, C plus I plus G plus NX. The only difference would be that in this case, instead of T is equal to T bar, you will here use T is equal to T naught plus T1 Y. So accordingly, you'll find C by plugging in over here. T is equal to T naught plus T1 Y rather than T is equal to T bar. So the process is exactly the same. You'll still first find your demand function, but instead of T is equal to T bar, you will use T is equal to T naught plus T1 Y, and then you'll just find equilibrium Y by setting Y equal to the demand schedule you found. And once you do that, you will find equilibrium income equal to this. Now, what you want to do is we want to essentially see how does the relation between taxes and output affect the value of our multiplier. So let's do a mathematical comparison first. Now, our old expenditure multiplier, when T1 is equal to 0, when you have fixed autonomous taxes, is 1 by 1 minus C1. Like expenditure multiplier would be, change in equilibrium income due to change in G bar or due to change in C naught or due to change in I bar or expenditure multiplier. If T1 is 0, then that multiplier we found earlier is 1 by 1 minus C1, right? But now new expenditure multiplier when T1 is not equal to 0 is we can see 1 by 1 minus C1 times 1 minus T1. So now let's compare them. Now we can see 1 minus C1, 1 minus T1. If we expand it a bit, this is 1 minus C1 plus C1 T1, right? Now this is the denominator of a new multiplier. We're just expanding that a bit, right? And this actually turns out to be greater than the denominator of our old expenditure multiplier because C1 and T1 are both positive, right? So they're greater than 0. We need to have a 0 here. So they both are greater than 0. Right? So they both are greater than 0. Because C1 is MPC, it's greater than 0. T1 is the texture, that's greater than 0. Because C1 and T1 are greater than 0, so denominator of a new multiplier is greater than the denominator of the old expenditure multiplier. Because in this, you're adding a positive number, right? In 1 minus C1, you're adding a positive number, C1, T1. So that's why the denominator of the new multiplier is greater than the denominator of the old multiplier. And now the numerators are the same, 1. Like the numerator of both the new and the old multiplier are the same, it's 1. But the denominator of the new multiplier is larger. So we know the new multiplier is smaller than the old multiplier because when you're comparing two fractions, they have the same numerator, but the denominator of this fraction is larger. So overall, this fraction is smaller, right? So mathematical comparison is very simple. We know that the numerator of both multipliers is the same. The denominator of the new multiplier is larger, so the new multiplier is smaller, right? So mathematically, we're seeing the new multiplier will be smaller. Now let's look at the economic intuition behind it. Now, for this, let's go back into a standard goods market model. We saw the multiplier exists because when income goes up, consumption goes up. That increases demand, which raises income, and which further increases consumption and so on. So if we go back and we look at the economic intuition behind our multiplier, right? So if we go back and we look at the economic intuition, so this was the economic intuition, right? Okay, when G increased, that increased demand, which increased Y. We said the multiplier effect exists because when Y increases, C increases, which further increases Z, which further increases Y, and so on. Now, when taxes depend upon income, what happens is when Y increases, taxes also increase. Over here, taxes were in the simple goods market model, taxes were T is equal to T bar. They did not change with income. But now when Y increases, taxes also increase. And as a result of this, the increase in consumption is going to be less because even though income is increasing, but now T is also increasing. So consumption now increases by less at each stage of this multiplier process. So the overall multiplier effect is smaller because even though now Y is increasing, right? But now taxes are also increasing. So C is going to increase by less at each stage in the multiplier process. So the multiplier effect is smaller. So this is the economic intuition. That when T depends upon Y, after a positive change in autonomous spending as Y increases, now taxes will also increase. So we know in our simple model, the multiplier effect is driven through an increase in C. But now that increase in C is less at each stage of the multiplier process because when Y increases, that increases T. So C increases by less at each stage, so the multiplier effect is smaller. Now, since taxes that vary with income reduce the size of the multiplier, proportional income taxes are often referred to as automatic stabilizers. Now, the term automatic comes from the fact there is no deliberate action by the government to change taxes. Rather, they're changing automatically in response to changes in Y. So you're not deliberately changing anything. The taxes are changing automatically due to changes in Y. For example, when you're in a recession, tax revenues will fall as income goes down, even if tax rates remain constant. So the term automatic comes from the fact there's no deliberate action. Taxes are changing automatically in response to changes in Y. The term stabilizer comes from the fact that the multiplier is now smaller when you have proportional income taxes. So when autonomous spending changes, output will vary less, right? Because of a smaller multiplier, when autonomous spending changes, output will vary less. So the smaller multiplier will reduce the impact of changes in autonomous spending of Y. So proportional income taxes are known as automatic stabilizers, where automatic comes from the fact there is no deliberate action by the government to change taxes. Rather, these taxes are changing automatically due to changes in Y. Y goes up, taxes go up. Y goes down, taxes go down. That's the way we have defined them. T is T naught plus T1 Y. They have an income induced or income related component. But as Y changes, automatically taxes change without the government having to come and change the tax rates. Stabilizer comes from the fact that they're reducing the value of the multiplier, which means that when autonomous spending changes, the output will vary less. It will tend to be more stable. So it will reduce the impact of changes in autonomous spending on Y. So that's why proportional income taxes are known as automatic stabilizers.